the important thing here about all of these elements is that if we go down and we look at the atoms of all of those elements, in other words, the smallest part of those elements, which can't be broken down any further by normal chemical means, every one of those elements in the first verse of Tom Lehrer's song and all the rest of his song, every element has a different looking atom. Now, if we just were to look at them through a very special kind of microscope, they might all look the same to us, but they all behave differently from a chemical point of view because they are made up of different numbers of, I'll mention the word protons, you might have heard it before, in the nucleus of the atom, and they have different number of electrons in the outer parts of the atom, and the electrons will be arranged differently. Every one has a unique atom, and that is something we must remember. That defines an element, and there we had just a small taste of them. Now I want to go back to that list, and I want to show you some of the symbols that we use for these elements. Antimony, interestingly, is SB. Now, the symbols that we use are not always simple abbreviations. Arsenic is. Aluminium, or aluminum as the Americans say, is Al. Hydrogen is H. Oxygen is O. Nitrogen is N. Very nice. First letters of those elements. Rhenium is RH. Nickel is Ni. Neodymium, I think I've got this right, is Nd. Neptunium is Np. And it has to be different from nitrogen, of course. Iron, now it's Fe. Why? Because iron is not the original name for this metal. It's a name that we've given it, but the original name was well known to the Romans, and they called iron ferrum. So we talk about ferrous metals and non-ferrous metals. It means metals involving iron, whose symbol is Fe, and the non-ferrous metals, of course, would not have any iron in them. Americium is Am, ruthenium is Ru, and uranium is just U, because there are no other elements whose names begin with a U. So we have shorthand terms for, or letters or abbreviations for all of the elements. And this really makes our life so much simpler. Imagine if we wanted to write down water as being an oxide of hydrogen. We would write down hydrogen oxide. And that's not what water is called. We give it an even shorter name than that. But just for example, so you write down hydrogen oxide, and it's a long, cumbersome thing. You can only get about 2 compounds in a line of page. So what we do is we abbreviate them, and the start of the way that we abbreviate them is to give each element a unique symbol. Now I'm going to show you the symbols of all the elements, and you might know, and you may even have on the back of your science class at school, you might have seen a table of the elements. Now it's called the periodic table for a particular reason that we don't need to go into now, but the table of the elements is a big table with every single element written on there, and again, we don't write it out in full unless you see it in small letters underneath the symbol of the elements. And here it is. Let's take a look. There is the periodic table. Now, we're not going to see all the details because some of this is a little dark, so I'll point out to 1 or 2 of them, and maybe we can focus in just a little bit. But the way this is arranged, it's arranged in a very specific order. Number 1 over here is hydrogen. That is because it is the lightest of all the elements, and it contains only one particle in its nucleus. There is helium. Here's lithium, beryllium, and it starts as though I'm starting to sing the song again, but I'm not. And then we'll go to number 5, which is boron, 6 carbon, 7 nitrogen, 8 oxygen, 9 fluorine, and 10 neon. Now, normally you only have to deal with the first 20 elements, so it takes us up to there. Na is sodium, and that's obviously, there's some Latin connection there because Na doesn't sound like sodium at all. In fact, it stands for natrium, and that is still a word used in Afrikaans. Mg is magnesium. Al, there's aluminium, or what the Americans would call aluminum. Si, silicon. P, phosphorus. S, sulfur. Cl, chlorine. Ar, argon. K, potassium, kalium, and Ca, calcium. All these, many of these words end in IUM again. But what we see there is an arrangement of all of the elements. Now, that arrangement, as I said, carries a very important significance. For a start, every one atom that is, let's say it's number 10. Atom number 10 will have a bigger nucleus, and therefore it'll be a heavier atom than the atom of the previous element. Now, number 10 is neon, and it will have a heavier atom than the previous one, number 9, which is fluorine, than the previous one, number 8, which is oxygen, and so on. For another very interesting reason, it doesn't always mean that just because something is slightly heavier, that the atom is therefore bigger, because the way that the electrons are arranged around the outside of the atom, sometimes they contract a little, and they contract for very good reasons which you can understand, because we spoke about charge a little while ago. Now, if the center of the atom is charged and the outer parts of the atom have got negative electrons in them, they attract one another, and maybe there are just enough positives in the middle to attract those outside electrons and squeeze them in a little bit, pull them in a little bit, and make a smaller atom. So we can't always say that just because we're going up in sequence from 1 to 2 to 3 to 4 to 5, that shows you the size of the atoms. It doesn't necessarily show you the size of the atom, but what it does say is that every one is going to be slightly more massive than the one before. It has more mass in it. And there is your periodic table. There are all your elements. There are all the abbreviations of the elements. And you see these things in the middle here. There's ruthenium, and there's rhodium, and here Au, let's see, there it is, that's gold, and that's platinum, both very important metals for South Africa, and every other metal is arranged on there. Just take a look right down at the end here. These along here are the or many of them are the so-called, from about here, are the so-called man-made elements, or you see there's uranium. These are beyond uranium, so they are called the transuranic elements. Okay.